Hello everyone and welcome back for another video. And in the last video, we looked at serialization in Hive. In this video, we're going to be creating a custom component in Hive so we can have more of a look into how serialization works. It also is a good kind of starting point for us to start creating a more complete custom component. So the first thing we're going to do is start creating our component files that we're going to need. That means our Python file, our definition file. So in PyCharm, inside of our custom ZooTools package we created in another previous video, we have the video tutorials. In here, we have a namespace called Galaxy, and then we have two sub namespaces, apps and libs. In the libs, typically in ZooTools, you'll find that all of our internal code and libraries are always inside this folder. In the apps, you always basically find our UIs, our individual tools, and so on. So in the libs folder, I'm going to create a new Python package, and I'm going to call this Hive. Inside of the apps folder, I'm going to create a new Python package called Hive Artist UI. Inside the Artist UI, I'm not going to do anything inside here actually, because I'm going to demonstrate that you don't require a component widget every single time. It just depends on what your kind of widget's doing and how much customization you need. Inside of our libs Hive folder, I'm going to create a new subfolder, and I'm going to call this components. In here, we're going to create a new file. I'm going to call this custom component. I'm great at naming, so we're going to roll with that. And I'm going to create a definition called custom component as well. It's important that these names kind of line up a little bit. I'm a big fan of consistency, so just keep it all the same. Inside our Python file, we're just going to import the Hive API. Then we're going to create a custom class. So we're going to create a custom component. Inside here, we're going to inherit from component. Then we're going to create a class variable, and that's going to be definition name. That's going to be our custom component. You gotta remember one thing is that pretty much all the way through ZooTools, we don't, when it comes to like plugins, which is like what a component is, we don't use the class name as a registry name. This just allows us to completely change it behind the scenes at any given time for more, like we need to change how the inheritance works on site and everything. We completely change the class name and it doesn't really matter. So the definition name becomes the key within the registry. There is one thing we have to do before we even work with Hive itself in the UI is to create our required method, which is the setup. And I'm just going to pass on that. I don't have to do anything here. We don't even have to do any code other than this to get our component up and running. But we do need to create our data. So we're going to go into the definition file. And in here, we're going to create a dictionary. And then I'm going to start with a few different keys, some really important ones to just make sure that internally everything works fine. So the first one is going to be the definition version. This basically tells Hive what kind of version of the definition you want to use. And pretty much this is always going to be 2.0 unless we release a new version. Then we're going to create a version for our component, which is going to be version 1. That way you can detect later on if your version of your component changes. That way you can react to that and do things like upgrades or migration or anything else. The next thing inside this, I'm going to create a name for our component. Now, this name is not really all that important except for its user facing. It's a default name you get in the Maya scene. So I'm going to call this just custom. And we're going to create a default side label, which is going to be Now, what we're going to do is create a new key, which is called guide layer, because we want to create some guides. Now, this is actually a dictionary, and we're going to create a key called DAG. And that's going to be a list. Now, there's two more keys you can work with, but we'll get to those keys at a later date. So the first one is going to be a required guide that we always need in every single component, and Hive won't build your component without it, and that is the root guide. Now, the Downside to working with a definition is you have to do this by hand every time. Obviously, having a UI for editing your component would be much more useful, but we don't have that luxury right now. So what I'm going to do is just enter these things. I'm going to do this completely from scratch. Typically, I would just go to another component and copy paste the definition and then just strip out anything I don't want and add anything that I need. But for this video, we're going to do it by hand. So I'm going to call this root. I'm going to give it an ID, which is going to be the internal ID. This is unique identifier. That's a reserved identifier, by the way. So it has to be that name. We're going to create a children key, and that's going to be an actual empty list for now, because we'll fill that in later. We're going to give it a pivot color. This is the color of your actual pivot that you see in the minor scene. So this is going to be a list, and that's going to be 0.800. That's going to be like more red. A pivot shape is basically going to be a string. So in that case, that's going to be cube bounding. The parent is going to be null. That just says, hey, just parent to the world. And it's going to do the necessary parenting to the actual guide layer underneath the hood. Next one, I'm just going to make sure that we pass in the Hive type, which is going to be guide. This just allows our code to detect, hey, this is a guide and not something like a completely separate kind of node that you want to add into the scene. Now we could put in translate passing like these, locations, but we're actually going to handle that in a completely different way. And you'll see kind of how I typically work with definitions when I'm doing the base definition. Like mainly it's around serialization and how you can work with templates to streamline your alliterations on your components. The next thing I probably want to do is fill in one actually really important key, and that's a required key, and that is going to be this SRTs. The SRTs is only required for the root. Everything else you can do whatever you want with it, but the SRT for the root is actually required, and that's because of the way that your component gets connected to other components. So if you want to drive your component by something else, then what it does is it creates a constraint from that component to your guide, and it uses the SRT to do that so that you have control over the root guide itself, so you can change the location. I'm just going to call this root guide SRT, like so. There is a required key for the component, and what you're doing here is linking between the definition and the Python file. So this is going to be custom component, right? That custom component type is the same thing that you enter here in the definition name here. Now, there's one more step, and it's a bit of a gotcha, is that if you go into the zoo package JSON, is that this Hive doesn't know about your component yet. It doesn't know how to find it. So when it tries to register your component, well, it doesn't exist because you haven't specified where it is. So we need to add a couple of keys to our zoo package JSON. First one is going to be the Hive update component path. And I'm just going to create one more, which is going to be the Hive definitions path, I believe. Yes. And that's also going to be a list. Typically, I use lists because more of an additive thing. You don't have to. You can use, and I like to keep consistency between wire keys. You can actually just use a string, but by using a list, ZooTools will work out platform specific behavior for joining paths together for you. So the path for our component is going to be our location for our file, which is going to be this location. So I'm going to start with this part, Hive, and add in Hive components. And do the same thing with the definition. We have two different paths for this because we do that in Hive internally, and we separate the definition and the actual file at two separate folders. You can do whatever you want to do. In our case, we're just going to put it in the same folder. We'll add our UI component widget a little bit later. So hopefully, if we've done everything right, we should now be able to go into Maya and just do a reload inside the developer menu and go to Hive Artist UI. Now you can see that we have our custom component here. And you can see it's not actually called custom component, it's called custom. This name, Hive UI, will actually strip out the component section from your type label that you specified in the definition. It will just remove the component section. So that's why it's only just custom. It's not using the actual name key. Now we should be able to double click it, and if everything's all good, and it is, we now have our root guide in the scene. And you can see we have a widget that's already been filled in with all the properties that we actually require. Now, if you add new guide settings, it'll automatically populate into the UI view, and that means it's kind of just procedurally building it from your definition. You can't control the UI from the definition, so that's why you have the ability to create custom widgets instead. And because you typically want more control over certain things as well, like drop downs and so on, like space switching here and the naming conventions. So from here, we could now start changing our component with new guides. So what we want to do is add some new guides to this and get it to build. And then what we're going to do is create a control, a couple of joints, and get them connected. So let's do that. So to create a new scene, I'm going to go into PyCharm here, go into our component, custom component. Now, all we have to do to create a new guide is just copy paste, because we're going to shorten some of the development time. Copy paste the actual guide layer for the root, and just put it inside the children key of the root. And I'm going to change the ID. Now, you can, when you come with IDs, they are fixed in place. So once you've shipped your component publicly, it is incredibly hard and quite dangerous to change your ID, because that can break tools if they rely on it, and it will break your component in terms of updates as well, because now you have a differing ID. It is possible to manage that, but it's a little bit more of a pain right now, and it's something that I am planning to look at. I'm just going to pull this up. I'm going to change the null to be root. Otherwise, it's going to get parented to the Hive guide layout root transform, which is not the right thing. Now we have the pivot shape. I want to change that to sphere. The SRTs I don't need anymore. And we also need a control shape. This control shape is going to be used for the animation team. So I'm going to just give it a name for now. You'll see how we actually elaborate on the shape very soon, and how Hive actually deals with this. So this is only temporary. I'm just going to keep this a circle. It doesn't matter for now. So now, if we go back into Maya and do the same thing that we did last time, do a reload, go to custom again, and now you see we have our guide. It's a bit red, so we'll change that in the definition a little bit later. But now, if you go into control visibility, you see we now have our custom animation control. And now what we can do is go into our control creator, and I'm just going to change this to something a little bit different. So let's make this a cube, and I'm just going to give it a new color. So let's make this green. And now what I'm going to do is change the location. I don't want it world space 0 just for now, so we can demonstrate how the serialization works. So, and how you can actually use templates to shortcut your development process. So we have our guide, we have everything there, but now we want this position, this update. So let's say we change the rotation here of our guide, and we change the scale, right? Now we want this to be reflected inside of our definition, because every time we build a component now, we want this setup. And this also means that if I go into this guide and change the aim and up, it's always going to be there. And those new changes and everything else that we change is always going to be there. To do this, all we have to do is go into our template section inside of our Hive Artist UI and go save rig as template. And we just save it. I'm just going to do this. It's only going to be a temporary file. So now we have it there. And I'm going to do is open up the template location. So I have the custom template there. All we need to do is now bring this into PyCharm. So we now have it in PyCharm. All we need to do is go Control-L, and that'll format the whole file. Now all we need to do is go to the section where it says components, and you'll see a section here called custom component. Any changes you make in the UI in the scene is going to be reflected here. You can also see down the bottom here, we have inside the children of the root is we have our shape right here. And it's no longer a string, it's now a dictionary. And now that actually represents what we've actually made. So I think it's our cube. What we can also do is I'm going to change the pivot color of this upper guide, and I'm going to change it to yellow. So everything else here, we're perfectly fine. So what I'm going to do is just take the root here, I'm going to copy it, go into our custom definition, and I'm just going to replace this section with the root. Now if we save, go back to Maya, just on a reload, and now we go back into the UI, do a build of our custom component, and you can see that now we have the changes, but where's our control? Well, we just need to show the visibility. So we just iterated on that. All we have to do to create more guides is just to add it to the definition, right? So what we can do is just add 2 more, just for demonstration purposes. And then after that, what we'll do is create a control and some joints. So I'm just going to grab our upper section. I'm going to copy it. I'm going to go into, the children section. I'm going to paste it. And then what I'm going to do is change the name. I'm going to say mid and go down to the parent. The parent is really, really important. It's something that I am planning to rectify so the parent is not required in terms of the actual setting. So that's done based on the hierarchy of the JSON, but for now, it's fine. Now, what we can do is just, once again, I'm just going to go Control Alt L format, just to help me a little bit. I'm now going to copy the mid section, and I'm just going to go into the children section for the mid guide and do another one. I'm going to rename this towards M. I'm going to change the parent to mid. All right, now we have essentially what's the equivalent to an arm. What we now can do is create a new key because I'm going to create some joints. And this is going to be for our definition. I'm going to do the exact same thing, go to DAG, right? And the format, once more, is a list. Now I'm going to copy this from a component that I've already built. All right, so what I've got here is the definition set up for all our joints, and that's going to be our output for the actual skinning joints. You got to remember that all our skinning joints go into the deform layer, and there's special functionality behind the scenes to manage all of that. Now, there's important things to kind of keep in mind here. To have things done automatically for you, it's not a requirement to have this because there is ways actually to manage this. So that things can be different, but it's really easy if you keep things consistent between your layers. So what you'll find is that our IDs are the same between guide layer and the deform layer. There is ways, so you can make this something like mid IK and then have the guide layer remap itself to that particular joint in the deform layer. That is something that we'll do at a later time. It's built into the component to allow you to do that. But we don't want to have to do that right now because we don't have to do some extra code that we don't really need it right now. So you can see we still have the parent, we specify as a joint, and we also specify the ID, right? So now if we go into Maya, go and remove our guides, do a reload, open up our UI again, build our custom, everything looks the same, but if we go into our outliner, we now have 3 more guides, or 2 more guides. So now what we can do is just take this guy, and I'm just going to move that down in world. So I'm just going to move that out there, out here, and if I go and say align selected, you can see it kind of automatically happens, but it's not ideal depending on what you're doing. And we'll get into auto align and how to fully customize that and some of the basic ideas behind the map, but I'm not going to go through how containers work. But typically, by default, you will just align to the very first guide, but we can completely customize that and how it actually aligns and what guides to align to and whether it needs to at all at a later date. So once we have this, we can now go and if everything's set up in our deformation line correctly, we should be able to go and build our skeleton. And now we have our deformation, right? Now that's all our joints. And you can see that's underneath the deform layer HSC of the root of the rig. What we now want to do is just for basic do some basic code. So we take these controls, and we can now build animation controls. So we have this, but we haven't said, hey, what is our rig looking like? So for example, if we go into rig, we only have our joints. We have no animation controls. It doesn't do this automatically because the animation rig typically is more complicated depending on what you're doing. So Hive right now can't just fully automate that. That's something that's on my list because I know how to do it. It's just very, very time consuming. So I'm just going to go back to guides, and I'm just going to go into controls. I'm just going to change one of these shapes and make it something else. It's simple enough, and we can do something with it. Of course, we could save this as a template again and copy paste the definition across, and we're basically done, and this will be our defaults. So I'm just going to do that again, just for reuse a little bit later. And if I grab our guide layer here, we don't need to worry about the joints. So grab that section because I don't need the section here. We'll go through that another time. And just paste it. All right, so now that'll happen every single time. Now if we go into our code, we want to be able to generate our controls. Well, it's actually pretty straightforward. To save some time, I'm going to copy and paste some code. All right, so this is all it takes. Is not that much lines, that much code. It's not really doing too much right now. All it's doing is going to create controls. It's not doing any kind of binding to joins or anything like that. But you'll start to see kind of some basic behavior. We grab our meta node for the rig layer, right? So that way we can create our controls and bind it to the rig layer so our tools can manage to utilize those controls, knows how to find it. It also means that when Hive deletes your control rig when you go between build modes, it knows what to delete. We grab the main parent node that we're going to be using, which pretty much is going to be the parent node here. This parent node on the setup rig is actually the joint, so you basically just go parent joint. But we don't need that typically. The only time you really need to worry about that is if you need to grab the parent component's position of the output. So we have the root transform of our current component. Then we're going to loop over our guides, right? And we're going to skip the root because we don't care about it. That's only for our guide layer and for organization purposes. Next thing is something you probably haven't seen before, which is our naming system. So naming configuration is set up automatically for you. It is something we'll deal with at a later date. This function here will configure your naming convention up front, and then everything from there on will be using that configuration that you've specified for your current preset that you have active in the rig in the Hive Artist UI. If you change the naming preset that you have here, let's say we go into the UE5 preset, and that's the one we want to use, right? So we can just go and do that. Now, when we build our component, it's going to use the custom component configuration that we have in the UE5 preset. At the moment, there's none. We can also go into the naming convention section of our actual widget and change the override here if we need to, right? At that point, our code is going to automatically adapt to that, and every time we build, it's going to use that naming convention. Then we're just going to create our control with the translate, rotate order, the shape, and the parent. We don't pass in the scale, obviously, because we don't want scale on the rig. We also pass in the ID, so the ID matches between our guides and our control rig. That is not a 100% requirement. We do have a base standard for our convention. So, for example, if you need IK or FK in your control rig in the rig, what you would do is something like constants.ik type, and what that really is just a lowercase ik, and just depends on at the end. And it's the same as what we do with the arm, the legs, and so on. So with this, we now have animation controls. So if we go back in Hive, we don't need to rebuild. We just need to reload our code and then build. So I'm just going to build. Now we have our actual animation controls. And you can see here that here's our controls. Now if we unblack box, you now have it underneath the rig layer because we've parented to the root transform. And you can see it has no XRTs, but you can add them in as well. We haven't done everything here. We don't have a connectable component, so we don't have the ability to control our component and parent it up. So if we want to parent this to a spline, currently we're not capable of doing that. We only have a component that works by itself, and that's it. And we don't even have the joints connected. We don't have a lot of things. Now, typically, I could actually do the joint setup right now. So might as well. If I go and instead of getting brick layer, I'm going to get the form layer. Right now, what we can do is instead of this one's the kind of computationally slow way, but you can, there's different ways of doing this. So what I'm going to do is go to form layer, joint. And what I can do is pass in the guide def.id, right? And that's going to look for it. The alternative and faster computational way, because what this is doing is actually going through the metadata. So every time you do this, it's doing the same thing over and over again. So the better way is to go and say find joints. And then what you can do is essentially do something like this. Okay, so one thing you kind of have to know is the order of how these find joints work. And typically it's creation order. So if you create it in specific order, it'll basically work like that. So this is one way to do it. And then what you can do is simply, because I kind of know that's going to be the right order, and we can always test it, we can just do a zip over the top of those two. So here is go to guides, joints, right? So you can do it that way as well. And now you can have access to the actual location in the Miocene. So when you work with the deform layer from self.deform layer, you're accessing the Miocene through the metadata. If you're going through the definition and doing the deform layer, you're actually getting the data, not the Miocene nodes. Then from here, what you can do is go zappy. We have an add import. And the first one is going to be the driven object, which is going to be our joint. Then it's going to be our drivers. So drivers is going to be, this has the ability to do space switching at the same time. So you need to set this up. It's a little bit more work than, say, using CMDS or something, because CMDS doesn't actually deal with space switching for you, whereas this does. So the train type here, we'll come back to the other key, is going to be the parent. And we can maintain the offset, that's fine. And you can actually turn off tracing. And what that'll do is don't worry about the metadata. I'm just going to leave that on. Now we need to set up the targets, right? So this will say, hey, what parents, what is going to drive this particular joint? And that's going to be our control here. So there's a bunch of keys relating to this, especially around space switching. We can touch on that at a later date when you want to kind of do this manually, but there is a much better way of doing space switching. It's just sometimes if you want to do this in a way that ZooTools doesn't currently support, then doing it by hand like this is actually possible. But we'll get into the actual whole way, which will give you support in your component for the UI, and that's done through the data as well. So the first key is going to be targets. In here, it's going to be basically a list of nested tuples, whether you like it or not. And we're just going to basically pass in the full path and just pass it particle name. It's not really going to do anything in our case, but it's good just to do in the first place. And I'm just going to pass the control. And because it's nested tuple, I'm just going to do that. Now we have our guide def, our joints, everything's in the right order. Just going to look at that. Now, as long as our build order is the same between our guide layer and our deformation, then what's going to happen is it's going to return the exact same order between the guides and the joints. But this doesn't always, this may not be true depending on your situation. So sometimes, depending on how you want to create your constraints or how you want to do your connections, the creation order is not the same depending on just how your code is driven and all that kind of stuff. So if we go into the actual find joint section here, you will find that it returns a list, right? So the returned list from the metadata is the return list you've got here, and that's the actual IDs that you've got here. So it's the same order that you've got that you pass in, it's the order that you get back. So it's kind of consistent in that way, and it makes code much easier to actually read and work with. This is the same for this section here. So now if we go back into Biome, and as long as I did everything right, we can just do a reload. ZooTools has been reloaded. Now we go to UI. I'm just going to go back on into the skeleton. That'll just delete the animation rig. And now we basically go back into rig, and you can see that we've created constraints here. And if we go into the controls, you can see now we have a basic idea of creating an FK chain. Nothing too fancy. We could do a lot more with this. So for example, there's one thing we have to do cleanup of all this. So for example, here we have the actual local transforms. We want to get rid of that. That can be done pretty easily. So if we do that right now, I'm just going to create SRTs by just doing. This means you can actually create multiple SRTs at the same time. So if you need one for like driving attributes, like an SDK or direct-driven attributes, you can do multiple SRTs at the same time. Space switching will do its own thing underneath the hood. So with this, just for the sake of it, I'm just going to say name plus SRT. Typically, I would actually also run this through the naming convention system, but for now, that's fine. And what we're going to do is drive this by the actual control SRT. All right, so reload again, go back in the HiveArtist UI, go to skeleton, do another build. And now you can see that we have no local transforms here. And if we go and make sure our black box is off, and we go into the rig layer, you can see we now have an SRT. Obviously, the naming convention is wrong relating to the SRTs, but we can definitely change that out later on. The guides are all there as well. So we've basically done what we need to do. Like, this is perfectly fine to run with to a certain degree, but we need inputs, we need outputs, we need to be able to have support for connecting to our component. We need to do validation, we need to do space switching. There's all sorts of things you have to worry about. So in the next video, we'll start going through these kind of areas where we have to start supporting connections, we have to do ID remapping and space switching and so on, and naming conventions. So hopefully you've learned something, and hopefully this wasn't too much, but this is very, very simple. It gets way more complicated, not because it's Hive, it's because the way rigs are built that need to be more accommodating for a wider audience in Hive than just say you're just individual studio. So if you go through our components, there is a lot to cover. So I'll see you in the next video.